Okay, we're now going to do Chapter 4. Chapter 4 is titled More Linear Equations and Inequalities. And the reason they say more linear equations and inequalities is that they're going to pick up on the things you learned in Chapter 3 and expand upon those. Specifically, Lesson 4.1 is solving percent problems using equations. So the big idea of Lesson 4.1 is that many types of questions that involve percents can be written in a very simple form of ax equals b, and then you solve for one of those three things. Either you're solving for a because they give you x and b, or you're solving for x because they give you a and b, or you're solving for b because they give you a and x. The homework, actually it's not homework any longer, I've called it practice work because as long as you're watching the videos at home, you're doing that work now in class and practicing it with other people to answer your questions. So let's do some of these percent problems. So we're going to put percent problems into this form of ax equals b. That's the form. And it's more helpful to think of it as p times q equals r as opposed to ax equals b, because the p, the q, and the r stand for words that are easy to remember. P stands for percent, which we're going to put either in a decimal or fraction form. Q stands for quantity, and r stands for result. But as you can see, it obviously is still that form. So there's three possible ways a percent problem could be set up. It could be this one, or this one. The first one, we're solving for r. The second one, the result. The second one, we're solving for q, the quantity. The third one, we're solving for p, the percent. And we're going to do each of them and see how you can use the same form for all three problems. So the first one, the question you would be asked is something like 12% of 85 is what number? And again, you're going to do p times q equals r. So p, percent, would be 0.12 in decimal form. Of, in our sentence here, of is multiplication in math. 85 is our quantity. Is equals in math. R is result, what we're trying to find, what number. So 12% of 85 is what number? And there it is, all in one equation. 0.12 times 85 equals r. Okay? And if we solve for that, it is 10.2. R equals 10.2. The next one that they do, they're going to solve for q. And what that is 7% of what number, the thing we don't know this time, is 91. 7% of what number is 91? 7% as a decimal of multiplication. What number, the thing we're trying to solve for, is 91? Then here it is as an equation. 7% of what number is 91? And what we would do to solve it, as I'm sure you recognize, is we would divide both sides by 0.07. And when we do that on the left side, all we're left with is q. And when we take 91 and we divide it by 0.07, we get 1,300. So 7% of 1,300 is 91. The last one you possibly could see in a percent problem is solving for the percent itself. What percent of 160 is 38.4? So percent of 160 is 38.4. This one we're solving for p, the percent, so we're going to divide both sides by 160. And when we divide the left-hand side of the equal sign by 160, we get p, that's the only thing we have left on the left-hand side. When we divide the right-hand side, 38.4 times 160, we get 0.24. Now if we rewrite that as a from a decimal rather to a percentage, 0.24 is 24%. So what percent of 160 is 38.4? Well, 24% of 160 is 38.4. And the last thing they mention in your book, and I just thought I'd put it here too, is a piece of sort of historical information. Percent comes from the Latin words per centum, meaning per 100. And that actually makes a lot of sense if you think about it as cents, as in money. 100 cents is a dollar. So just a little piece of trivia. Okay, now let's talk about these percent problems and how they might be applied to real-world situations. Very common ways that they're applied to real-world situations that we can relate to are purchasing things. So you might be purchasing something and it might have tax on it. That would be a markup. Or you might be purchasing something and before it's taxed, it might go on sale, and that would be a discount. So let's say something got discounted and then it got taxed. You could have both a markup, the tax, and a discount, the sale price. First, let's look at them each independently. So let's look at if something got marked up. Now, by the way, another common way that you see markups is problems associated with giving a tip to a waitress or waiter. Okay, so you have a particular price, and I think this one I actually took from your book. It was one about giving a tip on a restaurant bill, and the bill was $36.50, and they said that they wanted to leave a tip of 18%. So what you do is you take 1 and you add how much you want to mark it up by, so 0.18, that's 18%, okay? And that's your now what's called your markup. So my $36.50 of my bill times 1.18 equals 43.07. So if we wanted to leave an 18% tip, we would leave 43.07, $43.07 for that particular bill. Okay, now let's look at, instead of a markup, a discount. And obviously an obvious way this would be applied is if something was on sale. So if we had something that was $320 as its original price, and it was discounted by 15%, well, we take 1 and we subtract 0.15, and that gives us 0.85. So the original price times 0.85 gives us a discounted price of $272. Okay, so that one's a discount. Let's combine them together in one problem. Okay, so we're going to have both markups and discounts in the same problem. We have an item that's original list price, and it gets discounted because it goes on sale. So we would say the original price times the discount would give us the discounted price. And then in most states they charge you sales tax. So that discounted price times the markup of the sales tax would give you the final price. So here's one that started at a price of $2.50. It was discounted by 25%, so the discount is 0.75 multiplied by the original $2.50. And now our discounted price is $187.50. But let's say they give a tax, sales tax of 6%. So our markup rate, 1 plus 0.06, is 1.06. So $187.50 times 1.06 equals $198.75. So that item that was originally $250 gets discounted by 25% to $187.50, then gets marked up with a 6% sales tax to a final price of $198.75. They could ask you a couple questions about this situation. They could say, well, how much did I save? Okay, well, if it cost $250 and it was discounted by 25%, I saved $62.50. That's one way to calculate that. Another way to think of it is, if it was originally $250 and I had a discounted price of $187.50, then I saved $62.50. Obviously the same thing, but two different ways to approach it. The other thing besides how much did I save, you could say, well, how much did I pay in tax? Well, if the item's price, final sales price, was at $187.50, and I paid 6% sales tax, then I paid $11.25 in sales tax. Second way of looking at it, my final price was $198.75. My pre-tax price was $187.50. So the amount in the final price that was tax was $11.25. Again, two different ways to calculate the same thing. All right, so here's a summary page. Now, this is the way they say it in your book, and it's a little bit possibly confusing because up till now they kept referring to 1.00 plus something like 0.06 being a markup, and 1.00 minus something like 0.15 being a discount. Okay? Now, in this thing that they put in your book of the summary, they, instead of using 1.00, they use 100. So I was just consistent in the way they set it up, but it's really the same thing, because what you end up with here is 1.15, okay? Down here, I'm sorry, no you don't, I lied. 0.85 rather, because that was a subtraction. Down here is the addition. You end up with 1.06. So in the discount you subtract, in the markup you add. What I was saying was that they use 100 here instead of 1.00, but it's really the same percent. The difference is they're referring to percentages here, okay? So 100 minus 15 would give you 85%, and 85% is the same thing as 0.85. 100 plus 6% gives you 106, which is the same thing as 1.06. So they just use two different ways of writing the same thing, but they really are saying the same thing. And that is lesson 4.1.